In this presentation, we're going to go over a very quick and very basic overview of what engineering is and the type of the things that engineers do. Before we get too deep, I guess we should talk about what is engineering. So engineering is the application of math and science to better and improve life. So once again, the engineers aren't going out and creating or finding new truth about the universe, but they're taking what we know and using that to solve problems to better or improve everybody's life. If that was engineering, what are engineers? An engineer is a person who is trained in and uses technological and scientific knowledge to solve practical problems. And it's most basic, that's what engineers do. They take what they know and apply it to solving a problem. That leads to the question, what do engineers do? We're going to talk about 5 of those: research, develop, design, supervise, and manage. They're not necessarily exclusive of one another. As an engineer, you're going to touch on each and every one of those sometime in your career, or combinations of those early in your career. Research. The purpose of research is to employ basic scientific principles in the discovery, discovery, and application of new knowledge that will have commercial or economic value. So in this case, the engineer is working a little bit like of a scientist to discover something new in terms of knowledge. But then the engineer is going to take that and apply it. That's why it has application there. Apply it so that it will solve a problem. Now, that's wrapped up in the language of commercial or economic value, because most engineers, if not all of them, are working for a company, and companies exist to make money. So the projects you'll be working on will solve problems that have commercial or economic monetary value. And so when you're doing research, you'll develop or existing or invent new products. And then here's the tie-in with science. You'll just discover truth. But the engineer then goes and applies it. So engineering is the application part. Development. Development is the construction, fabrication, assembly, layout, and testing of scale models, small pilot models, and experimental models for pilot processes or procedure that will work. So development doesn't necessarily deal just with new discoveries, but it does use well-known principles, and you know that you're close, but you're then going to construct and fabricate scale models to see what you can do, how best to solve that problem. Development can involve searches in libraries, manufacturing literatures, and patents for existing ideas that you could then apply. Once again, know that the engineers use to apply their knowledge. All right, and it's not copying, it's seeing what other people have done and see what you can pull from that to put into your design that's still your own, that solves this problem in its own way. But that effort that somebody else has put into it, you can then use to assist you for ideas to put in your design. And this is the pictures there are a couple of projects that I worked on. When I worked at Bullard, we were playing with thermal imaging cameras, and we wanted to have a piece of glass because this glass could be coated in such a manner that it decreased reflections greatly over plastic. Also, glass tends to perform better when you take it into fire, and that's where the thermal imager cameras were being used by the fire service. However, as you can see from our tests, glass tend to break. And so this was a piece of glass made by Owens Corning over in Versailles, Kentucky, and they had much more improved performance, but it wasn't quite developed to the point for our application with, I'll put the caveat, with the current design that I had there. You also have design. So when you design something, you're going to anticipate all manner of problems that the user may create in the application of a machine or use of a structure. But basically, that's fancy words for you're going to think of all the ways they can be stupid with it. So how can they misuse it? How, if you have somebody who's not very educated or somebody that's very, very educated and they think about this and they try to use this, how are they how are they going to approach it? And a lot of times you have to determine that through your own deductions, but also building prototypes and watching others use it. Hand it to them and say, here, turn this on. This is used to prevent user errors, prevent accidents, and dissatisfaction. Have you ever tried to get the lid off of something and you can't? That makes you unhappy. On the other hand, have you ever opened something and the lid's already popped? That also makes you unhappy. So you have to anticipate, if I put it on too hard, people may not be able to get it off. If I make it too easy, it may detach when I don't want it to. This requires a mastery of basic engineering principles and math and an understanding of the capabilities of machines. It also requires an intense questioning and observation of everything around you, because you're going to take what you see in nature, what you see other people already done, and put those into your design. Supervise. So if we looked at design and development, those are both things that I did when I was at Bullard. I also supervised a couple of draftspeople, 3D modelers, that take my 3D models and then they built assemblies from them, they built engineering drawings from them. You have to be able to engineer, you have to be able to work closely with the technicians, mechanics, and laborers. So those are the people that you're going to ask to build your device. And you have to be able to speak their language. In many ways, that's being able to fabricate things on your own, to use the machines that they're using, to make a connection with them and be involved in their lives and to know what they go through to build something. Because as you're developing and as you're designing, part of that anticipation of user needs is how people that put it together and how the manufacturing process can be easier for those who are putting it together. Because you can have the same device that does this exact same thing, but one takes 10 minutes to put together and one takes 2 hours. Other engineering tasks, production and construction. So we have project engineers that supervises other engineers on the jobs. Typically, I would probably call that an engineering manager. That's usually, they usually term into, in the factories that I worked with and the companies I worked for, that was an engineering manager, usually called director of engineering. But you can do that as an engineer, and you must have knowledge. They prepare the schedules, though I think that's more of a plant manager, which is coming up for production or construction. They must have knowledge of engineering principles and visualization skills. They must be very detail oriented. They must work well with others. What other functions do engineers perform? Operations or plant. So this is a little bit like what the last slide. They maintain the building. They set up routine tasks that others will do. They will observe, debug, modify, direct others to maintain complex automated machinery. You have to know a wide variety of mechanical, chemical, electrical engineering branches, manufacturing engineering, industrial engineering, because you're going to compare costs one day, you're going to set up a schedule for production on the same day. You will be in a meeting to determine which machine should we buy. You will then go out to the plant because there's an emergency, because an injection molding machine is down, and you have to debug why is it no longer functioning. You must be able to work with people and machines and know what to expect of both people and machines. Sales engineer. Sometimes engineers, the product is complex, or you're selling directly to other engineers, so they are more comfortable having somebody who can speak their language. So you'll present the new product to prospective customers, but you will know with intimate knowledge, from the nuts and bolts to the entire assembly, how to educate the users, to answer questions that they have. You can talk their language and answer technical questions. If you're selling to a plant, like a giant piece of machinery that's going to go into their plant, you know how the rest of their plant works. And then be able to show how that your piece of equipment over anybody else's will fit best into their plant. Management. A large number, and this is not just management of engineers, this is management of an entire country. If you look at the Fortune 500 companies, something on the order of almost half of them are run not by somebody with an MBA or a business degree, but by engineers or scientists. So you can use the design process that you learn in this class to also solve problems that are related to business and not necessarily just engineering. And they make decisions about everything. We got equipment, plant, labor force, financial assets. If you're management or CEO of a company, you make all the decisions. What product areas do we move into? How do we change existing products to make it better? Who do we hire? Who do we fire? Do we grow? Do we shrink? So you're into everything in that. You also have the management, the business side engineer that you must work hard to develop. It's not, as you move into management and as you continue with your engineering degree or career, it's not just being able to know processes and people and how two items will fit together or how to do CAD. You have to understand the business side, because no engineering activities should occur if you don't understand how money is going to be made from it if you work for a company, because their existence is to make money, and they choose different ways to do that. And so as an engineer, you need to become concerned with long-range effects of policy decisions, whether that's financial, legal, or involving the people out in the plant.